Well, hi, and thanks for joining me here at my shop. I'm going forward and basically I'm removing all the capacitors that were installed here about 20 years ago. That's really what this is amounting to now. The capacitors I've replaced so far, many of the molded ones are testing kind of so-so or okay but not perfect, so that's prompting me to carry on, along with the fact that two resistors continue to operate at high temperatures. It doesn't seem correct, and I don't know why. And so that's why I'm busy doing this. I'm working in this area of the radio now, and if you look, you see there's a huge terminal strip through here. The outside ones are screwed into the chassis and grounded. So the two outside ones are grounded to the chassis, but the rest of them are not. When you see one of these things in a radio with parts all over it, what you know is that it's going to be really hard to sort what's going on here against the schematic. So the way I try to deal with that is I make a pictorial sort of diagram that kind of matches the way the components are laid out here. So then I just start looking for components I should be able to identify fairly easily. So for instance, this guy is hooked directly to a terminal on this tube. I can find this terminal on the schematic, and voila, I'll find the capacitor. Then I can write what it is, C45, and how much, 0.3 microfarads. This one was easy because one end is connected to this tube. The rest of these have not been easy to do at all. I've been in here for quite a while, slowly tracing my way through here. Now sometimes instead of making a component to component connection, there'll be a wire in between. So there'll be a component here and a wire run all the way to somewhere else, and a component hooked up to the wire. And sometimes those are done on spare terminals. There's just 1,000 things here to throw you off track. There's no doubt about it. This can be coupled with the potential that some of these replaced parts are the wrong size or in the wrong position. I mean, there's the potential for that. Mistakes happen. I make them too. So I need to verify all this, and I'll just jump ahead a little bit here. What prompted me to make this diagram and take all this time was finding this wire appears to be going to the wrong terminal. That's what set this off. So for me to determine that this wire is going to the correct terminal, I gotta figure out what all these are doing in here. Along the way, it's forcing me to test some of these resistors that are in here. A couple of them look like they're high. So it looks like there's a lot of restoration work just in here. That's what I'm working away on. I'll just show you something I found. The reason I turned the cameras on at this point is I found something interesting, and when I poke at it, the interesting thing will go away. So I want to do that on camera. It's a little bit embarrassing. I'm showing my own work here. So we're looking. Let me show you where this is on the radio before I get carried away. So we're going to look right up in behind here where there's a hidden resistor, right here. I'm going to take a look at it. So what it is that is of interest here, let me just get the angle right so I don't get too much light. Okay, the interesting thing is back behind here on this green capacitor which I installed. There is something hanging down. Why does this look so different than it did? So you can see something right behind the resistor hanging down here. Oh, okay, so that was what I wanted to catch on camera. Was there a contact here? So this is probably a lead. It's actually quite hard to, let me move the other one. Maybe I just move this capacitor here down a little bit further. Just to get it away from that thing. Push it in and down. There we go. Yeah, that's probably just a wired tail from one of these components, probably from this capacitor here. Now while I'm looking at it, look at that resistor. So I was trying to identify this resistor. The color bars on it, well, I don't think those are color bars anymore. I think those are fried. The orange, nothing yellow, orange. What? So I don't think we can trust those colors at all on there. That one is supposed to be, and I'm in the middle of figuring it out. So I'm going to stop now and carry on trying to figure this thing out. Look at that resistor up there. It's not looking so healthy either. There's the replaced resistor, and then two more. One of those isn't looking terribly healthy. So, you know, there's a reason why all these capacitors got changed 20 years ago. The reason could be they were simply paper, and the technician at the time decided just to do them. That looks a little suspicious there. Or there may have been problems. They may have been cooking up. I think it's okay. And my own solder connection here is not looking so good. This one here. Huh. I think it's okay. That's the thing, you know, as you work away on these radios, you can easily be introducing problems without knowing it. Making mistakes, solder didn't work the way you thought. These things are hard to see. You know, I'm in here with a camera looking at this stuff. Look at how big it is. If you're looking at this on a big screen TV, this thing's leaping out at you. But I guarantee you, looking at it with your eyes, you're not going to see as much. Okay, I could sit and stare at this all day. There's a ground terminal not being used out there. Look at that. Looks like that is just tacked on there. That's this one here. No, maybe not. Well, I'm going to be replacing this anyway, so I'm going to poke around with it right now. Okay, I'll continue working on my chart of my diagram, and once I get that done, we'll take a look at it and then make a plan for how to approach these capacitors and anything else that might be weird, like that wire that may be in the wrong spot. Okay, well, I think I found a wiring error which is really paralyzing me at this point because I really have a lot of doubt with what I'm doing. So I put the schematic up on the screen, you can see it, and this capacitor and most importantly this wire don't seem to be adding up. So I'm going to trace it right in front of you here and see if I can discover my own error, if there is one. So we're starting with this wire, which is connected on the back of this switch. Okay, so on the schematic, the switch is here, and this is the wire. The wire comes up, it meets a resistor and a capacitor. So we follow that wire over, particularly if I get it on the TV here. So that black wire connects to this terminal. From this terminal, leaving from that terminal is this resistor here, and there's nothing in behind here. Usually I'm quite uncomfortable sticking my finger in a radio like this, even though I know it's not powered. There's nothing behind there. So the wire comes to a terminal and leaves in a resistor. But on the schematic, the wire, oops, I got to point to this. The wire comes to a terminal, goes through a resistor, but also goes through a capacitor. Now we're going to start, so there's something going on here. Now we're going to start on the other end of this. We're going to start with pin 5 on the 6C5, pin 5. Okay, so we'll find pin 5 here. the 6C5 is which one, Jim? Wow, it's way down here. It's way down here. So here's the 6C5. Okay, we take pin 5. 1, 2, 3, 4, 5. 5 in the dark there. There. 5 connects to this capacitor. Oh, sorry about the camera work here. Connects to this capacitor, and you follow this wire, and guess what? It goes all the way back up into here. So this is the wire here. So this is the pin 5 wire from the 6C5. Pin 5. So looking at the schematic now, pin 5 wire. Help me, I'm losing it. I'm losing it fast. Pin 5. So we look at pin 5. That's right where my cursor is pointing. Right at pin 5. You come out of pin 5, you encounter a capacitor, and then you get on this wire and head towards, on the schematic, a combination resistor capacitor. That combination is right here. Resistor and the capacitor right here. Mica capacitor. You come out the other side and you encounter a capacitor. Here it is here. This one. And on the other side you run through this capacitor, and from here you're supposed to encounter R19. Guess what? I'm going to prove this is correct. It's coming along through here. That's why I'm doing it again. Connect to this terminal. On this terminal there's a whole pile of stuff. You see, so we go through the capacitor. And this terminal. Wait a minute, I've gone and confused myself here for crying. I gotta back up. So capacitor through here, through those two in parallel, through this capacitor, and we're reaching this point. This point has a capacitor. There's one there. So that's probably, wait a minute. Okay, I lost my mind again. So going back to these two that are, this is probably, or I could guess that this is some kind of biasing resistor capacitor combination, grid leak type biasing here. Go through it, come out the other side, we're into that C25, I think it is. Come out the other side is C25. What do we encounter? A wire to the switch. No, we don't. The wire to the switch is here. And what else should we encounter? Wire to the switch and one resistor R19. Okay, so where's R19? Up in here. So this would be R19 right here. This thing I got my finger on. So you're encountering R19, you're at the wrong end of it. This guy, pretty sure, should be connected where this black wire goes. So let's try it once again. I think I got it. Okay, so it's coming from the back of the switch here. This wire comes to this terminal. From this terminal, it can only reach this resistor, R19. So we look on the schematic now, the wire comes up, there's R19, it should also be reaching C25. C25 should take you back to the combo, but C25 is not connected there, it's connected in the wrong place. I think that's really the case here. This could be the explanation for overheating. Capacitors, based on what? Based on, I don't know. Based on hope. So I'm pretty sure this guy's wrong. So we're going to leave it as is. I'm going to carry on here. This is going to give me a stroke doing this kind of stuff. Okay. So if the video never finishes, you know I suffered a stroke. Okay, well, you know what, the conclusion I've reached here, this is what's in my head at the moment, is I'm going to have to just redo all the componentry across here. Redo the whole thing. Get all these parts out, resistors too, and all new parts in, done properly. It's a lot easier said than done. And I have to think about an approach to doing this. You know, stripping away all these parts and then starting over. Wow, that's an approach. I think I'd be more inclined to do little sections at a time or something to try to work this out so it's the least risk of introducing a new mistake. Because in my case, that risk is real. It's really real. I find it easy to make mistakes doing this kind of stuff. So I'm going to think about that for a while before I get into it. Surely I can do a few without committing myself to the whole thing. And now I've got many of them identified properly. I will think about this a little bit. It's actually lunchtime. Lunch is over. Now it's time for me to decide what to do here. So I think I'm going to kind of work in from the edges. You know, some of this stuff's pretty easy to do. These over here. It's really this stuff in here that looks pretty monstrous. So I'll clean up these far ends, I think. And replace all the components through here, resistors and all. The only problem I found in terms of wiring so far is this situation with this capacitor. I think everything else is actually quite correct. But as I go along, what I'll do is each time I do a component, I'll once again verify it against the schematic and the like. And while the camera's rolling, why don't we nip out the first capacitor here on this end. This great big one. This is supposed to be a 0.1. It looks pretty big to me. So let's just pop it in here. 0.25. And it looks to be in great shape. 0.25. Now that is, oh, it's supposed to be a 0.3. Let's test this right away. I think this one's going to test good, but let's see. I mean, it looks great. $50 volts. Grate open. 150. Grate open wide. So I think this guy's in great shape. 400 volt capacitor. Let's go to 250. Yeah, open right up. This is a like new capacitor. I'm supposed to have 0.3 there, not 0.25. Hey, let me hook this back up. Let's find out what its capacitance measures out at. Just giving it a chance to discharge because I hit it with a 400. 250 rather. Is that all? 250? Okay, over we go. A 0.25 is going to show up on this scale. You see that open right up there? Look at that. So it's another indication of a good capacitor. Down here on the scale, it's pretty much dead on 0.25. So there we are. This is a nice capacitor. They cut it out to find out. Yeah, 0.25 may have another place in that radio. Okay, so 0.3, eh? 0.3. Okay, I'll put something in there. Okay, so I've been working on this a little bit. You can see I've got my 0.3, which is really 3 0.1s put in parallel, getting them ready to solder in. I've got this one ready to replace the capacitor that was there, and I'm looking at this resistor, which is why I turned the cameras on. So that's yellow, purple, yellow. That's 40. What's 470? Should be 470K. And what does it really read? Let me repeat this. this here. Do it like this. I don't know. Let's see. Should settle in around 750 or so. 782. So there's no way that this is a 470k resistor, because I would read that or something less. Only way to read something more is the resistor itself is above this value here, or this value. That's way off. That's way off. So I'm going to replace that guy too. With a lot of stuff happening right in here getting replaced. Okay, it should be a 470 right here. How do they come up with a 0? Oh my gosh, it got up. That's off by a factor of 1,000. Whoops. Good thing I double check these things, eh? Okay, let's try this guy. This is a different type of resistor. I believe this is a 1 watt resistor. These guys are really pretty rugged. Is it it's supposed to be 500k, this one. Pretty close, 496. So it's fine. In a 470, this is just fine. Resistor to be visible here. This is snugged up a little too tight. You can pop it out front. Now, there's something very curious here. This wire. So this wire, look, it's not original. You can tell from the color in it. This is not original. It's connecting this terminal, which is grounded. You can see the screw going through it to the chassis here. That's grounded. It's going around and down to this terminal on the tube. It's tacked on to the terminal. There was no wire connection here before. So this is quite confusing. And then the wire carries on. It's very hard to see, but goes up and grounds to a grounded terminal up here. So he's got a wire running from a grounded terminal to a grounded terminal. So that raises a couple questions. One is, well, what the heck is this for? How can this help anything? Number two, was it supposed to go somewhere else? And he made a mistake and stuck it here? Is it supposed to go over here or here or here or where? This isn't the original wire, so what was he thinking? Did he not see that this was grounded back here? Is the grounding defective back there? Is it not really grounded? So you had to bring the ground down on a piece of wire. And why such a long piece of wire? I mean, your tendency would be to run a short piece back here. I don't know what he's up to here. I don't know what I should do about it. Now, if it is ground to ground, it's harmless. And why don't we start with this? This pin here, which has become grounded by virtue of this connection now. Let me look in here and see. Interestingly enough, that's pin number 8. Pin number 8 on a what? I can't remember. Pin number 8 on the 6J7. Is that right? No. Pin number 8 on the third tubes on the 6Q7. Pin number 8 on the 6Q. I'm looking at the schematic here. 6Q7. Pin number 8 is the cathode, and it's grounded. That really raises a question then. Okay, so is this a replacement wire? Yeah. Maybe that is an original wire. It just sort of doesn't look like it. It will almost certainly be one of these cloth covered style wire, not a plastic covered wire. What was he doing, and more importantly, what should I do? Just remove that? I can hear myself say yes. Now, we'll check and make sure that the terminal I just disconnect, maybe one or the other is not grounded the way I thought it was. Let's see if they both have maintained ground. Let's see here. So unfortunately I don't have a beeper meter here that's gonna, you know what I do? I can put it like this. That's not my meter. That's the meter. Okay, we're looking for that. I mean, how can this not be grounded here? On the other end, how can this not be grounded? So my meter misbehaved a little bit here. Watch the meter. That's why I don't usually use this continuity setting. Where's the beep? There, isn't that more reassuring? So what he was doing with that wire, I can only guess he didn't see that one of those two terminals was grounded and felt he had to extend a wire from one to the other to achieve the grounding it needs. I don't think that's the case. So it's just a little bit unsettling to undo what someone else did in these kinds of situations, because you don't really know all the backstory and all this kind of stuff. But I think we're ready to solder in these, this, and we're done in this area. Okay. Start with this pile here. Heck of a lot to melt in here. I don't know. Solder has got the juice to do it. Whoa, okay, what? You know what, sometimes on the video, you as a viewer are hearing stuff I'm not hearing in the shop. So I'm going to put on my headphones here and then I'm going to hear what you hear. I'm gonna stick that soldering iron back on there. Oh my gosh. Okay, so it's probably some kind of weird ground loopy thing going on. I've still got the audio system hooked up here, and we're actually listening to it. I'm gonna get rid of it. You hear it now? Still hear it. What is it? Okay, let me disconnect the phono leads entirely. Okay, so there's the only way you can hear anything now. There either be electromagnetic radiation reaching into the microphone. It's just up here, right? It's just right above where I am. Or who knows? Who knows? Who knows? Here, let's try this again. Okay, so it's gone. Strange stuff. Add it to the list. The ever-growing list of weird stuff that goes on. Okay, I want to get this in front of the terminal here. I can't solder it to air. There we are. That's good. This one's pretty good too. Okay. What did I do with the solder? Oh, it's up here. Where I never put it. Go. It takes a while. Okay, and this one. There it goes. Terminal hot enough right up in here. It's plenty soldered anyway. Doesn't really matter. Plenty soldered. Cool that off. Whoops. Didn't quite mean to do that. Here, a bit of a awkward locale. Of course, we can send this guy upwards. Out. Oops. That's why I don't put it up there. Now, where'd it go? Way up in here. Oh! What happened? Okay, so the thing I was soldering to just popped right off the terminal. It was just a tacked on little piece of wire. So all that's left now is the terminal itself. Obviously, if you can do it, it's better to go right on the terminal. But often that's really a very difficult thing to achieve. This one's not so good either. I think there's a hole in there I can push it through. Yeah. Now what? Can't get in behind it there. This is fairly stiff. Oops. Putting a lot of pressure right on that terminal. I don't want to do that. Perfect. Well, not perfect, but better. Anyway, let me get one more squeeze here. Not really. But it's going to solder up okay. Pretty sure of that. Oh yeah. Lots of. Okay, so we've done this capacitor, this one, this resistor, all in there securely. Let's go test this other capacitor. Hold on. Major tangle up wires here. All ready and waiting. So this one looks to be in perfect shape. It's a good all. 200 volt. Where's the size? 0.1. Okay, 50 volts. Hey, how did my phone get on the floor there? 50 volts. I'm not able to see that. What happened? How come it's so different? Okay, you can see the gap now. There we go, 50 volts. Yeah, it's going to be perfect. So I'm afraid I picked another good capacitor to change, but like I said, the only way to know for sure is to get it out of here. And just, let's see, it's supposed to be a 0.1. Let's give it a try. 0.1 is going to be on this scale here. Eye opens right up, and what's it on? It's on 0.1 precisely. I mean, it's dead on. I don't even think my capacitor checker is that accurate. Maybe it is. So, as I said before, only way to know for sure is just to go through these parts. So we did find the bad resistor here. So next I'm going to kind of come in from this side work my way through, and then we're going to face the music with this wire and this capacitor and sort it all out. But I think that's it for today. Yeah, I think that's it for today. Carry on tomorrow. Thanks a lot for watching, and see you on the next video.